In this video, we present an overview of PCLAM software. PCLAM software is the user interface for the Model 1035MR compatible large animal monitoring system. The hardware for the Model 1035 is covered in another video. But briefly, it consists of data acquisition modules located near the magnet and near the patient, and a control gating module located near a PC that's running PCLAM software. The hardware can be configured with the PC either in the magnet room or out of the magnet room, and in either case with a remote display. Clicking on the PCLAM icon on the desktop opens the software. This window gives options for going to a setup menu to configure the monitor, or run SnapView, and we'll say more on this later, or to just go to the monitor display with the current setup. We don't have an animal connected to the system, so there's no physiological measurements. We'll present animal data later, but for now, we just want to introduce the structure of the main display. This monitor is configured to do electrocardiogram, non-invasive blood pressure, pulse oximetry, capnography, and temperature. Along the bottom of the display are a series of buttons, a message window, stopwatch, and the date and time. When the snapshot key in the lower left is pressed, 36 seconds of all previously measured data is written to a snapshot data file. This snapshot feature gives us an excellent way of making training videos without the need to sedate an animal. We will use SnapView to playback snapshot data files previously collected with an animal in AMR scanner. Snapshot and SnapView are covered in detail in a separate video. Here we're just going to use SnapView as a training tool. Using the exit button, we close PCLAM and then reopen it again from the desktop icon. But this time we open SnapView. We select a snapshot data file and run the viewer. The display presentation is very much like that of PCLAM with just a few exceptions. One difference is the keys in the lower left. In PCLAM they were snapshot and trend. Here they are setup, rerun, export, and print. We only have 36 seconds of data. But by right-clicking on the rerun key, playback will automatically restart after 36 seconds. Let's focus on the cardiac cycle. We can speed up the sweep and freeze the display. Note that the electrocardiogram is composed of the QRS complex, the neural stimulus that initiates the heartbeat, followed by a T region, when the heart is collapsing and blood is flowing, and finally the P region, at the end of the cardiac cycle. Blood is ionic and an electrical conductor. As blood flows in the presence of a strong magnetic field, an electrical potential is generated that superimposes with the animal's normal electrocardiogram. This blood flow artifact occurs in the T region, and it can be quite large. It is largest with larger animals and higher magnetic fields. The artifact negates the possibility of doing ST segmentation. The system automatically detects the R wave and displays a red dot, or in this case a red bar, in the cardiac sweep display. The number of red dots per minute determines the heart rate. The period is the time interval of the cardiac cycle. Note that the peak in the plethysmograph waveform is delayed relative to the R wave. The delay occurs because it takes time for blood to travel from the heart to the pulse oximeter sensor site, which in this case was the tongue. I'll restart the waveform and return the sweep to 6 seconds. Clicking the speaker icon turns on an audible indication of the heartbeat. There's also a speaker icon for respiration. Note, in addition to the red bar indicating R wave detection, there's also a white dot. The presence of the white dot indicates that a trigger pulse has been output from the system's control gating module. When gating is implemented, the output gate is sent to the scanner's control electronics to allow image data acquisition to be acquired synchronous with the cardiac and/or respiratory cycle. This allows cardiac CNA blood flow images and images free of cardiac and respiratory motion to be acquired. A detailed discussion of gating is covered in the 1035 operation manual and a separate video. The peak of the plethysmogram waveform is also automatically detected by the system. The indication that the peak was detected can be displayed in the cardiac sweep display. Right or left click in the region to the right of the red icon to select Plet Gate. Note that a red bar is displayed above the peak of the plethysmogram waveform. Both heart rate and oxygen saturation are calculated and displayed. On the left side of the waveform, a signal scale is displayed. The number gives a measure of the strength of the pulse oximetry signal. Weak signals will be 5 or less. Strong signals 10 or more. In this case, the number changes between 9 and 10 due to the auto gain feature of the pulse oximetry circuit. There is a control just below signal scale that allows the auto gain to be disabled. The NIBP portion of PCLAM's main display includes readings for systolic, diastolic, mean arterial pressure, and heart rate. The cuff pressure is displayed in real time in a manometer at the bottom of the NIBP display. Control of NIBP measurements is made using several buttons. On the right, the animal buttons select between small and large animal modes. BP Stat immediately initiates a measurement. BP Stop stops the measurement. On the left, the Auto button starts auto-cycling measurements every few or several minutes. Cont starts continuous measurements for 6 minutes or until BP Stop is pressed. To the left is a box where the time interval between successive BP measurements can be entered. Just below the box, the time since the last blood pressure measurement is displayed. Clicking the question mark opens a window with information about the NIBP measurement. The signal quality gives a relative measure of the quality of the last measurement. Numbers are typically between 10 and 100, with larger numbers indicating a stronger signal. NIBP measurements typically take between 20 and 60 seconds. Refer to the 1035 operation manual for additional information. The carbon dioxide waveform is displayed along with end-tidal CO2, respiration rate, and minimally inspired CO2. Click on the label on the left to change the measuring units between kilopascals, percent CO2, and millimeters of mercury. Note that a red bar is displayed above the expiration portion of the waveform. The number of red bars per minute determines the respiration rate. Since the respiration rate is lower than the cardiac rate, the respiratory sweep is normally slower than the cardiac sweep. The interfering effects of O2 and N2O result in inaccurate CO2 readings. However, the capnograph has the ability to compensate for this error. Right-click on the CO2 waveform opens the capnograph settings window. The percent O2 and N2O can be entered to compensate for interfering gas being delivered to the patient. The sample gas flow can also be set using the arrows at the bottom of the window. The settings can be between 50 and 200 milliliters per minute. Refer to the 1035 operation manual for additional information. Temperature measurements are displayed in the 5-minute trend, with the most recent measurement entered on the right side of the display. The system normally has one channel of fiber optic temperature, but a second channel is available as an option. 2 buttons appear at the bottom of the display. These buttons select which measurement is displayed in the trend and in the digital display on the right. Toggle between degrees C and degrees F by clicking on the unit indication. Reviewing the buttons at the bottom of the display, we already know that the first few are different in SnapView than in PCLAM. But the next buttons are all the same, starting with the gating button. The sysinfo button opens a window with software and firmware revisions and module status, which are covered in the 1035 hardware video. The color button allows color changes to be made for the display background, waveforms, and digits. The heater button allows control of the optional fluid heater system covered in the single pump fluid heater video. The alarms button allows high and low alarm limits to be set for heart rate, oxygen saturation, respiration rate, and temperature. The Quick Set button automatically sets the high and low alarm limits 5% or 2 degrees Fahrenheit above and below the current measured values. After making entries, click Apply. There's also a button to silence alarms for 2 minutes. Finally, there's a freeze key which freezes the display and an exit key to exit the program. Additional information is available in SAII Instruments operation manuals and on www.i4sa.com. Thanks for watching.